This is Geometry, Unit 6, Day 4. We're talking about similar triangles. What we know about congruent triangles is that corresponding angles have to be congruent, and also the corresponding sides have to be congruent. But for similar polygons or triangles, but for similar, it's not that they both have to be congruent. Two polygons are similar polygons if corresponding angles are congruent and the corresponding sides are proportional. Proportional means that the corresponding sides have to be a multiple. Very important that it's a multiple of some value. You might be multiplying by 2 or 3, or you might be multiplying by a half or 1/3 or 2/3. So it's not adding or subtracting to get to the other side. It has to be multiplying. If two triangles are similar, there's a symbol we're going to use that looks like so. It's similar, it's a lot like the congruent symbol, which is that shape with the equal sign underneath it. This is just that wave or squiggly line. Here, the idea was to use tracing paper, and the tracing paper would be there to help you identify if the angles were congruent. So, I don't have tracing paper in front of me at the moment, but what you would do, by tracing out one of the angles, we could then slide it over to identify that it was the same measure in the other triangle. That would show that the angles were in fact congruent. Are the triangles congruent? Well, the triangles clearly are not congruent, because remember, the angles have to be the same, which is true, but the sides have to be, corresponding sides have to be congruent, and they're clearly not. So are the triangles congruent? We would say no. And we would say that the corresponding side lengths are not congruent. They're not the same. What do you notice about the side lengths? How do they compare? How do the corresponding sides compare? Triangle DEF is larger than triangle ABC. That I definitely notice. There might be something that they're multiplying by, but I can definitely say that's something I notice. Next, we're going to talk about scale factor, and that is identifying what is that amount that you multiply by. We're going to check to see if the ratios of corresponding side lengths are equal. We're going to use the corresponding side lengths like we used to talk about with congruent triangles. So from the figure from the other side, the length of AB, if you turn back and looked at that, was 10. DE was 15. So those are the two side lengths. We know that 5 goes into both of these numbers. And when you reduce that, you get 2/3. That number right now doesn't mean a lot, just being 2/3. We have to see if the other ones become 2/3 also. So we get 8 and 12. Then we're going to simplify those by 4. So we get 2/3. So now we have 2 of the 3 corresponding sides matching. Now that's important. Let's see if the final side. It only helps if all the corresponding sides have the same ratio. So looking at CA, CA is 12. FD from the other triangles was 18. We can reduce that by dividing 6 out of both of those, and we get 2/3. So that helps verify that K is going to equal, which is our scale factor, 2/3. We're going to write the ratios of these corresponding side lengths in a statement of proportionality. Statement is a term that hints to you that you should be using letters. Proportionality, proportion, is telling you you're talking about the ratios equaling each other. And what's unique about this one, why it's not just a proportion, is that all your corresponding sides should have the same reduced fraction, so that you're going to write down all the corresponding sides because they all reduce to the same thing. So the first one we're going to talk about, sometimes we start out with the smallest set, so that would be BC and EF. AB and DE is another pair. They both reduce to 2/3. And then your last pair is CA and DF. So that is a statement of proportionality. It's a proportion because it's two fractions equaling each other, but it's even more than that because it's multiple fractions equaling each other. And it needs to be written with letters. List all the congruent angles. Well, looking back at the other pictures from page 8, we saw that angle A was congruent to angle D. If we were to match that up and use the tracing paper, that showed that A and D were congruent, B and E were congruent, and C and F were congruent. Now we have shown that the sides are proportional and the angles are congruent. So now we can write what's called a similarity statement. So there are 6 ways you can name that first triangle. Any of those ways would be fine. Now there are 6 ways to name the second triangle, but there's only one correct way that's going to match this order. So looking up here, A started out with D. A goes with D, so D has to go first. B matches the E, so it has to go second, and then F. You could not call that FED. You had to call that DEF to match the same order that you put your first triangle, ABC. When we look at triangles, triangles have a lot of different parts to them. We're very familiar with the side lengths. We know about angles adding up to 180. But a new topic we're going to cover is called an altitude. An altitude is a new segment that is drawn from a vertex that is perpendicular, forms a right angle. It's perpendicular to the opposite side. So those 3 altitudes are all going to cross at the exact same location. But our main concern is understanding that an altitude goes from a vertex and is perpendicular to the opposite side. A median is very similar to an altitude. It goes from the vertex and it finds the midpoint of the opposite side. And it connects that. So you're sure to have the same value on both sides of that midpoint. So if we divide that side into 2 equal parts, and we draw a segment that connects that, that's called a median. We find our median and divide that, well, our midpoint, and divide that into 2 equal parts. Then this segment is called a median. And notice that the medians will all touch at the exact same location. Here we have corresponding lengths in similar polygons. If 2 polygons are similar, then the ratio of any 2 corresponding lengths in the polygons is equal to the scale factor. So what that's telling us is that if we know the corresponding side lengths have a scale factor, then we know that their corresponding altitudes have to have that same scale factor, or medians have to have that same scale factor. When we come down here to example number 1, we're looking at our two triangles. We know the triangles are similar. Therefore, we know that they're going to have a scale factor, and all the corresponding side lengths are going to share that same scale factor. They will have grown by the same multiple. Okay, we're going to find the median Km. So this is the value we're looking for. But first we need to figure out the scale factor. Okay, to figure out the scale factor, we need to look for some corresponding parts. Here we have Jm, which is the first and last letter. Here we have Eg, which is the first and last letter. That's the whole length, all the way across. Well, we could call that 96, because that would be 48 and 48. We call that 80. That would be one option. But we can also, it's okay to use just half that length as long as they're both using just half the length of the side. They're both reduced already by a factor of 2. So we're going to say JL over EF. Did I say that right? JL over EG. Sorry. So JL, well, that would be the whole length. We're going to divide that by 2, and that's going to give us JM over half of EG, which is GH. So that's what allows us to say 48 over 40. And when we have those numbers, we're going to divide both of those by 8. 8 goes into 48 6 times, and 8 goes into 45 times. So it's 6/5. That is a value more than 1. So we know that we have to multiply the smaller triangle by 6 and then divide it by 5 to figure out what the larger triangle values are going to be. So now, since we know what the scale factor is, we often call that K, we're going to take that 6/5 and equal it to the altitudes. Notice the 6 is the value with the bigger number, and it comes from the same triangle with the JL, which was the one on top. So it's our Km. So its corresponding side length is going to be FH. Now those M and H are not part of the similarity statement because that's not one of the vertices of these triangles. It's just an altitude. It goes to the midpoint. That point, or any of the midpoint locations of the sides, they're not going to be located on your similarity statement. So we don't know what Km is, but we do know what FH is. That's 10. So we'll be able to multiply by 10 to get 60 and figure out that 12 equals Km. 12 is the median. On the next page, we need to determine if these two polygons are actually similar to each other. When we look at it, we can see that the shapes look about the same. Angle A and angle J, they seem to have the same measures. They're both 90, looking at the markings on it. Angle B has one tick mark, and so does angle K. angle C and angle L have the same number of tick marks, which is 2 of them. And then D and M have the same number of tick marks. So that indicates that the corresponding angles are congruent. That was requirement number 1. The second requirement was that the sides, the corresponding sides, when you make a fraction out of them, you have to get the same ratio. So we're going to try that. We're going to take A and B, AB, which is 8, and JK, which is 14. We're going to divide both of those by 2 and get 4/7. Now 4/7 by itself doesn't mean much. But when we start to compare it to the other sides, AD is 12, JM is 21. 7 definitely doesn't go into that, but 3 does. 3 goes into there 4 times, 3 goes into this side 7 times. So we get 4/7 again. So that's good. That does mean something. They need to match. I would suspect, definitely if they're similar, they have to be all the same. I would suspect that that's what's going to happen. So CD is 8, LM is 14, and that of course reduces to 4/7. And the same thing again, that reduces down to 4/7. So here we have the same reduced value for all the corresponding sides. So now we know the ratios are equal, so the corresponding side lengths are proportional. You want to be sure to call side lengths proportional and not another term. Some people make the mistake and call side lengths similar. No, the polygons are similar. The sides are proportional. So the scale factor we're going to use is 4/7. So we're going to write a statement of proportionality from ABCD to JKLM. That means that AB and JK, the first 2 letters and first 2 letters, BC and KL, CD and LM, AD and JM. That's a statement because it's made out of letters. That's a proportionality because these are ratios that equal each other. So now we're ready to write a similarity statement. We know they're similar because the angles are congruent and the sides are proportional. So ABCD, there are many different ways we can write the first polygon. The second polygon has to match that. So A started with J, or A corresponds with J, B corresponds with K, C with L, and D with M. So that would be the correct way to write your similarity statement. Last one. In the diagram, we know that FGHJ, so find that in your picture, LMNP, find that in your picture. We need to find a common ratio. That means we can use any of the corresponding sides. So thinking about your statement of proportionality, you could use any pair of sides that went with this shape. So we can use the first 2 letters with the first 2 letters, or any other corresponding pair of sides. So I often like to use the first ones if I have numbers for both of those. So FG happens to be 15, LM happens to be 12, and when I reduce that by 3, I'm going to get 5/4. So I'm going to say the scale factor is 5/4. So our scale factor, now watch this. what is the scale factor of LMNP to FGHJ? So the LMNP would go on top. So that was the number here, the L, so I'm actually going to call that 4/5. So looking at the way that they use the word to telling you how to set up your ratio 4:5. So to solve for the value of x, we look at the picture. We know that our scale factor is going to be 4/5. We know that the x is in the smaller figure, so it's going to go on top. So that's mn. And its corresponding side, when we come up to our similarity statement, mn is the second set of numbers, gh is the second set of numbers. So we know that those are both corresponding. So 4/5, x and 40. We're going to cross multiply there and get 160. I'm going to just keep my 5 on bottom. So 5 goes into 16 3 times with 1 left over. 5 goes into 10 2 times. So I know that the x, which is also called mn, is a value of 32.